In the last lecture, we had discussed about the mole concept and we had started talking about some important formulas regarding the mole concept. Now we will see some other formulas of this. So, till now we have discussed that number of moles is equal to given mass of a substance in grams divided by the molar mass in grams. Okay. The second formula that we had learned is number of moles is equal to given number of particles divided by Avogadro's number. Okay. Now, another formula says that in STP, what is STP? STP is standard temperature and pressure. Okay. Standard temperature and pressure is called STP. So, in this case, temperature is 273 Kelvin, that is 0 degree Celsius, and pressure is 1 bar. Okay. So, at 273 Kelvin and 1 bar, it is called STP, standard temperature and pressure. So, the rule is that in STP, volume of 1 mole of any gas is equal to 22.4 liters. Okay. So, in STP, volume of 1 mole of any gas is 22.4 liters. So, 22.4 liters is the volume of 1 mole of a gas. Okay. So, 1 liter is the volume of 1 by 22.4 moles of a gas. So, Z liters is the volume of Z by 22.4 moles. So, we can also say that number of moles of a gas is equal to volume occupied by the gas at STP divided by 22.4 liters. This is another formula. Okay. So, let's write this in short notations. Okay. Because now we will correlate them. So, let's say given mass of a substance is equal to W, given weight of a substance, and the molar mass is M. So, the number of moles N is equal to W by M. Okay. This is one formula. The second formula is number of moles is N. Given number of particles, let's say the given number of particles is capital N and Na is the Avogadro number. So, small n is equal to capital N divided by Avogadro's number. This is the second formula. The third formula is this. Okay. This is N. Let's say this is V, volume of any gas. So, N is equal to V by 22.4 liters. Okay. So, this is the third formula. Okay. Now, we can correlate all these formulas. So, let's see. So, see, in these three formulas, the left hand side is the same. We are equating number of moles to a lot of things. Okay. So, we can say that number of moles is equal to, in the first formula it was the given weight of a substance in grams divided by the molar mass in grams. Now, this is the number of moles. This expression also says the number of moles. So, we can equate this as given number of particles divided by the Avogadro's number. We can also equate these formulas to this third formula, that is the volume of any gas in liters divided by 22.4 liters. So, with the help of these three formulas, we can solve a lot of numericals and lot of problems from mole concept. Okay. So, number of moles is equal to given weight of a substance in grams divided by the molar mass of the substance in grams. This is equal to any given number of particles in a substance divided by Avogadro's number, and this is also equal to the volume of a gas in liters at STP divided by the 22.4 liters. This is to be remembered that this is at STP. This formula is not applicable in any other conditions except STP. Okay. So, now let us do some examples. The first question is, calculate the number of moles in 12 grams of oxygen gas, and B, the weight of 10 to the power 22 atoms of carbon. Okay. So, let us start. The number of moles in 12 grams of oxygen gas. Okay. So, we have the formula number of moles is equal to this. Here weight is given, so we will work with the formula of weight. Okay. So, oxygen has a molecular mass of 2 into 16, that is 32 AMU. So, molar mass of oxygen is 32 grams. Okay. So, 32 grams of oxygen is equal to 1 mole of oxygen. So, 1 gram of oxygen will be equal to 1 by 32 moles of oxygen. So 12 gram of oxygen will be equal to, we have this formula, given weight divided by molar mass. Okay. So we get this as 0.375 moles of oxygen. Okay. In the second example, that is the weight of 10 to the power 22 atoms of carbon. See, not moles, we have to find out the weight of 10 to the power 22 atoms of carbon. Okay. So, 6.023 into 10 to the power 23 atoms is equal to 1 mole of carbon. So, 1 atom is 1 divided by 6.023 into 10 to the power 23 moles of carbon. So, 10 to the power 22 atoms is equal to, according to the formula, given number of particles divided by Avogadro's number. This is the number of moles. Okay. We will calculate together. So, this is the number of moles. So, we have this equation. Okay. Number of moles is equal to the given weight divided by the molar mass. So, the molar mass of carbon is 12, we know that. Molar mass of carbon is 12 grams. So, we have the number of moles, that this is N. Okay. N equal to W by M. We have N, we know M, we need to find out W. Okay. So, W is equal to N into M. Okay. So, weight is equal to, N is this many number of moles, free moles, into molar mass is 12 grams. So, this comes as 0.2 grams. So, the weight of 10 to the power 22 atoms of carbon is 0.2 grams. Okay. Let's do another example. So, the second question says, calculate the number of millimoles in 1 grams of water. Okay. Now, millimoles is given. What is millimoles? We have learnt about the multiples and submultiples of units. So, 1 millimole is equal to 10 to the power minus 3 mole. Okay. So, basically we have to find the number of millimoles in 1 gram of water. Okay. So, first find out the number of moles in 1 gram of water. Molar mass of water is equal to 2 into 1 plus 16. So, 18 grams. Okay. 18 grams of water is equal to 1 mole. So, 1 gram of water is equal to 1 by 18 moles. Okay. Now, this comes as 0.0556 moles. Okay. So 1 millimole is equal to 10 to the power minus 3 mole. So 1 mole is equal to 1000 millimole, right? So 0.556 moles is equal to 0.0556 into 1000 millimoles. This comes as 55.6 millimoles of water. So 1 grams of water contains 55.6 millimoles of water. So let's do another example. A piece of iron 0.835 grams. So, how many atoms of iron are present in this given sample? Okay. So, a piece of iron weighs 0.835 grams. How many atoms of iron are present in this given sample? So, atomic mass of iron is equal to 55.8 AMU. So, we can say that molar mass of iron is equal to 55.8 grams. So, 55.8 grams is equal to 6.022 into 10 to the power 23 atoms of iron, right? That is 1 mole of iron. So, 1 gram will be equal to these many atoms. Okay. So, 0.835 grams is equal to these many atoms. This comes as 9.01 into 10 to the power 21 atoms of iron. Okay. So, we have done some numericals based on the mole concept. In the next lecture, we will do some more numericals and we will start with percentage composition. Thank you.